Hello everyone, welcome to Mathematics Minute. This is a program we know that is specially designed to help students in the study of mathematics. Please try as much as possible to subscribe now to our YouTube channel and like our Facebook page. Today we are still going to consider theory of logarithm, and the aspect we are looking at is equations involving logarithm. Equations involving logarithm. Remember that in our previous videos we have looked at other objectives as far as theory of logarithm is concerned. We have considered meaning of logarithm, laws of logarithm, simplification of terms and expressions involving logarithm. Then we also looked at logarithm by substitution. Now the last part is equations involving logarithm, and that's what we have to look at today. All right, so stay away from distraction and let us begin this wonderful journey. It's going to be a lovely journey if only you will not allow anything to distract you. So let's begin. Now we know about equation. At least if you have watched our videos, you must have also come across logarithm. So it means equation that involve logarithm. That means an equation where we have logarithm. That's what it means. Now we know about so many equations, like we have this 2x minus 1 equals what? 7. This is an equation, but it is just an algebraic equation. If you watch our videos on algebra, you will actually know more about algebraic equation. An equation is a statement that uses a quality sign. See the quality sign, we have 2x minus 1 equals 7. That uses a quality sign to show that two expressions on both sides are the same or are equal. That's what makes this an equation. There must be an equality sign separating both sides. That's when it is equation. If I have just 2x minus 1, just this expression is not equation. So now, the equations we want to consider, they are not equations of this form, but equations that contain logarithm. And that's what we want to consider today, equations involving logarithm. Then we say any equation that contains a log operator is an equation involving logarithm. Examples, this. Now you see in this equation, because we have two sides separated by what? A quality sign. So this is an equation. Then what makes it equation involving logarithm is because of the presence of this log operator. The same thing here. In this case, we have more than one log operator. So once we have an equation containing this log operator, that equation is equation involving logarithm. Okay. Now we say there are three cases of interest in equations involving logarithm. We have different steps in solving problems in each case. We have different steps in solving problems in each case. Sorry for that mistake. So in each case, we have different method of solving problems in each case. Now, the first case we are going to consider, remember we said we have three cases. So case 1, that's what we want to consider now. In case 1, equations with one log operator. Look at this, just one log operator. This one, we have more than one. So the one we are interested first is the one that have just one log operator. So how do we solve such problems? So we say to solve such equations, we take these steps. What are the steps what steps are we going to take? Number 1, take note of the equation. Take note of the equation. 2, ensure that the term containing the log operator is alone one side of the equation, and also ensure that its coefficient is 1. Is 1. Okay? Then the third thing we need to do, take the base to the other side of the equation and let the term there become its power. Then 4. Okay, we have one more thing to add there. Then remove the log operator. Okay, 4. Simplify both sides. Simplify both sides. Then finally, solve the resulting equation in order to find the answer. Okay, so we're going to take these 5 steps. Don't mind the whole grammar. But by the time we begin to look at problems, you will now see that it is very, very easy. Why we have to put down the steps is so that we will look at the steps and then begin to apply them in solving this problem. So let's take equations or examples. Okay. Now, supposing we have if log 2x minus 1 in base 3 is equal to 2, say find x. This is an equation. So let's take these steps to solve. We're going to take these steps to solve this problem. Why are we following these steps? Because we are looking at equations with one log what? Operator. Equations with one log operator. So this is a typical example. We have just one log operator. So let's look at this. Log 2x minus 1 base 3 is equal to 2. They say to solve this, we take these steps. Take note of the equation. We have taken note of the equation. We know the base, we know the number, we know the other side. So we have looked at it, and we have also ascertained that it's the case we are interested in, the case where we have one log operator. Okay, they say ensure that the term containing the log operator is alone on one side of the equation, and also ensure that its coefficient is what? 1. If we look at this is the term. It stands alone on one side of the equation, so that's taken care of. We don't have any other thing. Maybe we don't have log 2x minus 1 base 3 is equal to maybe plus 5 is equal to 2. If it is in this form, it means that this term is not standing alone on this side. There is another term standing with it. So we must first of all make sure that this stands alone. In this case now, it's already alone. So there is nothing to do to this following this second step now. There's nothing to do. But if it's like this, we must make sure that we take away this. We are still going to see questions in that form where we apply that second step. Okay. Then also ensure that the coefficient of the log operator is what? 1. Now the coefficient here is 1. So the second step now, we don't have any problem. We don't have a situation where we need to do anything on this using the second step now, because there is no other term associated with this log term, and the coefficient of the log term is 1. If the coefficient is not 1, we must do something in order to clear that coefficient. Okay, so we move to the third step. Take the base to the other side of the equation and let the term there becomes its what? Power. Then remove the what? Log operator. Now we take the base to the other side of the equation. Look at the other side of the equation. Take this base there. The base is 3. Take it there. What did they say will happen in the process? The number there, the term there, use that term there as the power of the base. So let the term there become the power of the word base. So take the base to the other side of the equation. That's the 3. We are taking it there. And let the power there, make the power, the term there, the power of the base. The term here is 2, so make it the power of this base. That's what we're asked to do. Then remove the log operator. When you have done that, take the base to the other side of the equation and let the term there become its power. We have taken 3 there, the term there is 2, and it has become the power of the base. Then remove the log operator. This is gone. If you remove this, we are left with what? 2x minus 1. Okay? They say again, simplify both sides. Is there any side you need to simplify? Yes. This is an index form, so let's make it simpler. 3 raised to power 2 is what? 9. We have done that. This side is the new simplest one. This is the new simplest one now. So what's the next? They say solve the resulting equation. Can you see that this log equation now have reduced to ordinary algebraic equation? So if you will actually understand this, you must make sure that you know algebraic equation. So if we now solve, you remember how we do that. They say collect like terms. So if you are using the balanced method, add 1 to both sides and so on and so forth. So let's gather like terms. Minus 1 and 9 are like terms. Take minus 1 to the other side. We have 9. When this comes over here, we have 9 plus 1. So this will give us 2x. 9 plus 1 is what? 10. So to get x now, divide both sides. Divide both sides by what? By 2. So we have 2x over 2 equals 10 over 2. That will give us x equals what? 5. Beautiful. Very beautiful. And you remember you can always check your equation. If you take this 5 here, 5 times 2 will give us what? 10. So if you substitute 5 here, 5 times 2 is 10. 10 minus 1 is what? 9. So if you say log 9 in base 3, it will give you 2. Remember our simplification of log expression and terms. So we are going to solve more examples on this. We're going to solve more examples. We're going to take more questions so that we can actually illustrate this more and more. Okay, now let's go this way. We want to keep these steps so that by the time you must have mastered it, then we can train it. We will be making reference to it from time to time. So let's take another question. Question number 2 now. Question 2. Let's go this way. Question number 2. Wow. Question 2. Let's say, very simple one. Find y if log y in base 10 is minus 1. Very simple one indeed. Find log y. Find y if log y in base 10 is minus 1. Okay? The same approach. Log y in base 10 minus 1. Take note of the equation we have done that by writing it out. Then secondly, ensure that the term containing the log operator stands alone. This mighty man, this beautiful man, this handsome man is standing alone on one side of the equation, and his coefficient also is 1. So these two, we don't have problem there. Then take the base to the other side of the word of the equation. So the base is 10, take it to this side. And make that term its power, the term that is on that side. The term here is minus 1, let it become the power. Then remove the log operator. If you take away the log operator, you now have what remaining? Y. So y becomes, simplify both sides now. 10 raised to the power minus 1 is 1 over 10. So y is 1 over 10. We don't have any other thing to solve for that. So once we simplify both sides, they say solve the resulting equation, but y is already this. So we don't have anything to solve for that. That means we end it there. Okay, that's a simple one. So we take another one because that's why we are here. We take another example. You can always pause the video and make sure that you play it over and over again until you master the principles behind each of the solutions that we are giving you already. So can we take another one? Let's say we have log 3x minus 1 plus 2 is equal to 4. Let's say so 3x plus 1. Log 3x plus 1 then plus 2 is equal to 4. Okay? We already have our principles, so we don't have problem. We have our step. So we say take note of the equation. We have taken note of that. Log 3x plus 1 base 5 then plus 2 is equal to 4. Okay? They say ensure that the term containing the log operator is alone on one side of the equation, and also ensure that its coefficient is 1. It's not alone. We have 2 here. The coefficient is 1, so we need to deal with this. So because it's not alone, we need to take away these 2 to the other side, because the log term now is not alone. It's not standing alone like the first 2 problems we solved. So we are still going to apply the knowledge of our basic mathematics. We have 3x plus 1 is 5 equals 4 minus 2. This plus 2, take it to the other side, because we want to make this man to stand alone. So when we do that, we are going to have 2 here. We have log 3x plus 1. We have log 3x plus 1 is 5 is equal to 4 minus 2 now is 2. You remember this from the basic principles you apply in algebra while solving problems. Okay, we have dealt with the second step. The quotient is 1, so we don't have problem with that. Initially, we have a problem because this term is not standing alone, so that's why we have to take away these 2. Okay? Okay, that's the third question now, sorry. Now, we take this to this side based on the test step now. Take the base to this side, the other side of the equation. Let's do that. When you take this 5 to this side, then the term there is 2. Make that term the power of the what? Of the base. And then remove the log operator. So this man is gone, that man is gone. Remaining what? 3x plus 1. Oh, beautiful. We now simplify both sides. We have 3x plus 1 equals what? 25. Okay? Similar approach. We collect the like terms. 3x will give us 25 minus 1. 3x will give us what? 24. Divide both sides by 3. If you do that, we have 3x over 3 equals 24 over 3. At the end of the day, let's write the final result of here. X, when 3 divide, we are left with x. When 3 divide 24, we have what? 8. We have 8. Oh, beautiful. So I believe that you have mastered this step. You have mastered this step. So we're going to solve one more problem, then I will drop one for you to solve so that we'll conclude this part of equations with one log word operator. So take time and copy this. You can pause the video, copy it, then you play it again so that you make sure that you have actually grabbed or understood what we did here, the principles that we applied in solving this problem. It's very, very important. Okay, now let's go to question 4.